So as you can read from the title of this video, I'm going to show you how I've constructed my locomotive cradle. But before we get started, let's talk about what a locomotive cradle is as far as I'm concerned. So on the screen you see a rough sketch of what my locomotive cradle is going to look like. For me, a locomotive cradle is something that helps you to manhandle a locomotive if it's perhaps either too heavy or too cumbersome, or perhaps there's too many delicate parts on it for the locomotive to be manhandled just with your hands. You need something, some sort of tool to help you. Perhaps you've seen in an earlier video or heard in an earlier video at the start of the year that I'm expecting a new locomotive soon, and this locomotive will require a cradle. I have to stress that while I'm making this, the cradle, I haven't actually got the locomotive yet. So I'm playing it sort of half. I'm guessing the half of it, but on the other hand, I've got a mate who's got a similar locomotive. So if there's any sort of critical measuring or whatever that needs to be done, I'll go to him and use his locomotive. Let's get started. Okay, so what you see there on the floor is the travelling case for one of my current 3 locomotives, and they're all the same. I always use the same Stanley Fatmax. For the new locomotive, I'm just going to bring it into the picture now. That's the carrying box for the new locomotive that's coming shortly. So that's why I'm going to be needing a locomotive cradle, because it's going to be quite heavy. So here we are with the lid open of the Stanley Fatmax 28-inch, which is what I'm going to be using as a travelling case for the new locomotive. And what I've got in my other hand here is the base plate for the locomotive cradle. So I'm just going to place this in the Stanley Max. You see on the both ends of the carrying case there's a bit of the molded plastic that comes on the inside, and the locomotive cradle, the base, it fits exactly in between, so I'm quite lucky with that. Okay, so let's take a closer look at this cradle base then. It's made from 3mm thick aluminium. Okay, let's have a look at some dimensions. The base is 60 centimeters long. The internal width here is 15 centimeters, and the height of the edges is 4 centimeters. So the plan is, obviously with a locomotive cradle, you want it to be as light as possible, but you also want the locomotive to be as stable as possible while it's in the cradle when you're manhandling it about. So the plan is to have a wheel guide strip along the middle, so that will stop, at least at wheel level, the locomotive moving from side to side. So we're going to start with that. As if by magic, here we are at the next stage of the cradle build. So here we've got the strip in the center, along the center line. This strip is again 3mm aluminium, and initially I sawed it off at 59mm, and every 7.5 centimeters from the one end the back end, let's call it, I drilled holes to accept an M3 screw and bolt. If we look on the other underside, the bolts are countersunk, so this remains as flat as possible. So that's the center strip. Let's take a closer look at, let's say, the front end of the cradle. As I said before, the base aluminium is 3mm thick here, and testing with a smaller locomotive, I found that if you wanted to roll the locomotive onto the cradle, the 3mm is quite large obstacle to go over for the wheels. So what I've done, I've filed both above where both the rails are. I've filed that down to 1mm, and then obviously gradually from the 3mm thick down to the 1mm thick at the front, and I've chamfered the edges off so that the wheels can sort of, when you push the locomotive onto the cradle, the wheels will find the wheel guide for themselves, and that's fine with the locomotives that I have at home. So with the assembly in this state, I went to a friend's house, as he already has an example of the locomotive that I've got on order. And if I show you a picture when we tried to mount the locomotive onto this cradle base, you can immediately see that the buffer beam of the Garrett is extremely close to the rail, and this system here, that's not going to work because the buffer beam is going to foul the wheel alignment strip as it is now. Perhaps you can see a little bit further on, there's I've penciled in a line here. So we've sussed out that if I shorten the wheel alignment strip to about there, again with chamfered edges, once the front wheels of the first bogie of the Garrett comes up to the full 3mm height here, then it is clear of the strip. So modification number one is shortening the wheel alignment strip there. Modification number two concerns the fixing bolts for the wheel alignment strip. Because the amount of free play between the front buffer beam and this strip is so small, these bolts need to be mounted the other way around. So countersunk from this side and then nuts on the other side. So that's the second modification that I'm going to be doing shortly. So the third modification concerns the other end of the cradle base. If you imagine the Garrett coming on from the other side, we don't want it rolling off the cradle base the other end. So we need to have some sort of stop here. I've got here some 3mm angle aluminium, so that's going to be mounted something similar to that, but that means again that the wheel guide plate needs to be shortened. So with the end plate in place, I'm going to utilize this plate for a method of ensuring that the locomotive has minimum amount of movement this way when it's in the cradle. And how I'm going to do that is by using an eye on an M5 screw thread. That's going to go through the end plate at the correct height, Then I've got here some steel chain. So I'm going to take one link out, fit it permanently into the eye, and then when the locomotive comes on, the link will then go over the coupling of the garret and prevent motion that way. And to ensure that it's not going to move too much back and forward, I'm going to keep a little bit of pressure on the link by mounting some sponge here, so that the buffer plate is permanently pressurized against that sponge, so that will keep the link tight. So there's quite a bit to do, so I'll see you again shortly. So welcome back. So first modifications done, shorten the wheel alignment strip and just put a little bit of a chamfer on the end. So here's the other end of the cradle base then. The end plate, this is the end plate. The eye bolt is fixed in, and we've got the steel chain link that's got a slight kink into it to help it to stay fixed to the coupling on the garret. There's the other side of the end plate then. You see it's not mounted flush to the end of the cradle plate because of the limited space in the toolbox, the carrying box. I've lost about a centimetre of the total length of the cradle because of this, because of the bolt for the ring. So here you see the results of the second modification of the wheel alignment strip. The screws, or the bolts, let's say, holding the strip in place, they're now countersunk at this end, so there's no way that the buffer beam of the garret can foul itself while moving along in the cradle.